In this course, we will be covering the OSHA 1910134 standard for respiratory protection. This course will be broken down into 4 sections, including medical evaluation, fit testing, training, and a respiratory protection written program. Let's hand it over to Charlie, who will be our instructor for the evening.
So, a medical evaluation. Your employees have to fill out a medical questionnaire, and on that questionnaire it's going to ask their health of this and this and that, and then it needs to be reviewed by a medical practitioner at a minimum, all right, or a doctor or a nurse practitioner, I think. You can also get that done at respexam.com. Respexam.com is a website owned by 3M. It's $28 per employee. Fit tests. Now, a fit test can be performed by you on your own employees. You can learn how to do that. Or someone like ourselves does that, where I'm going to find a respirator that fits your employee. And, there's like 4 different brands I'll come to your office with, size small, medium, and large. When you guys buy a respirator at Home Depot, it's only got, size medium. And they don't have that many brands. But I'm going to try to find a brand and a size that fits your employee. So I got, like 4 different respirator brands, small, medium, and large, like 12 different respirators. I'm going to find a respirator, a half-face respirator, that fits your employee's face. I'm going to put smoke around their face, irritant smoke. They're going to sing a song and do a dance and run from here to there, and I am going to approve them, or disapprove them, but approve them to wear a North Safety 5500 series size large respirator. Now that's another piece of paper that you need as a business owner.
Next is a video about the different types of respirators that workers might use in their workplace. If your employer requires you to wear a respirator on the job, the Federal Occupational Safety and Health Administration, also called OSHA, and state OSHA agencies require that your employer select an appropriate respirator for you. A brief overview and general information about various types of respirators and some of your employer's responsibilities under OSHA's Respiratory Protection Standard will be discussed in this video.
This video is about the respirator fit testing requirements for any worker who is required to use a tight-fitting respirator. The Federal Occupational Safety and Health Administration, also called OSHA, and state OSHA agencies require employers to fit test workers who must wear these respirators on the job. This video provides a brief overview and general information about fit testing requirements under the federal OSHA or state OSHA respiratory protection standards. This video can be a part of the OSHA-required respiratory protection training, which includes many topics, like how to put on and take off a respirator and how to use, clean, and maintain your respirator. Your employer must also provide you with worksite-specific training. While this video discusses some of your employer's responsibilities under OSHA's respiratory protection fit testing requirements, it is important to remember that using a respirator that fits you properly protects your health and safety. A respirator can't protect you if it doesn't fit your face. It's that simple. Certain respirators, known as tight-fitting respirators, must form a tight seal with your face or neck to work properly. If your respirator doesn't fit your face properly, contaminated air can leak into your respirator facepiece, and you could breathe in hazardous substances. So before you wear a tight-fitting respirator at work, your employer must be sure that your respirator fits you. Your employer does this by performing a fit test on you while you wear the same make, model, and size of respirator that you will be using on the job. That way, you know that your respirator fits you properly and can protect you as long as you use it correctly. In addition, before you use a respirator or are fit tested, your employer must ensure that you are medically able to wear it. So, what is a fit test? A fit test tests the seal between the respirator's facepiece and your face. It takes about 15 to 20 minutes to complete and is performed at least annually. After passing a fit test with a respirator, you must use the exact same make, model, style, and size respirator on the job. A fit test should not be confused with a user seal check. A user seal check is a quick check performed by the wearer each time the respirator is put on. It determines if the respirator is properly seated to the face or needs to be readjusted. There are two types of fit tests: qualitative and quantitative. Qualitative fit testing is a pass-fail test method that uses your sense of taste or smell or your reaction to an irritant in order to detect leakage into the respirator facepiece. Qualitative fit testing does not measure the actual amount of leakage. Whether the respirator passes or fails the test is based simply on you detecting leakage of the test substance into your facepiece. There are 4 qualitative fit test methods accepted by OSHA. Isoamyl acetate, which smells like bananas. Saccharin, which leaves a sweet taste in your mouth. Bitrex, which leaves a bitter taste in your mouth. And irritant smoke, which can cause coughing. Qualitative fit testing is normally used for half-mask respirators, those that just cover your mouth and nose. Half-mask respirators can be filtering facepiece respirators, often called N95s, as well as elastomeric respirators. Quantitative fit testing uses a machine to measure the actual amount of leakage into the facepiece and does not rely upon your sense of taste, smell, or irritation in order to detect leakage. The respirators used during this type of fit testing will have a probe attached to the facepiece that will be connected to the machine by a hose. There are 3 quantitative fit test methods accepted by OSHA: generated aerosol, ambient aerosol, and controlled negative pressure. Quantitative fit testing can be used for any type of tight-fitting respirator. Many workers need to wear prescription glasses or personal protective equipment, such as safety goggles or earmuffs, while performing a job. If you fall into this category, then you must wear these items during the fit test to be sure they don't interfere with the respirator's fit. You must be fit tested before you use a respirator in the workplace, and you must be retested at least every 12 months to make sure that the respirator you use still fits you. You must be fit tested with the specific make, model, style, and size of respirator that you will be using. Not everyone can get a good fit with one specific respirator. If the respirator fails the fit test, then another make, model, style, or size must be tried until one is found that fits you properly. Therefore, your employer needs to provide you with a reasonable selection of sizes and models to choose from. When you've completed the fit testing process, it's very important that you know which make, model, style, and size respirator fits your face properly, and when and where you'll need to wear it for protection. Also, the fit of your respirator must be retested whenever you have a change in your physical condition that could affect the fit of your respirator. Such changes could include large weight gain or loss, major dental work, such as new dentures, facial surgery that may have changed the shape of your face, or significant scarring in the area of the seal. Any of these changes could affect the ability of your respirator to properly seal to your face, which could allow contaminated air to leak into your respirator facepiece. If you find that the fit of your respirator becomes unacceptable, you must be allowed to select a different type of respirator and be retested. The selection may include a new make, model, style, or size of respirator. Facial hair, like a beard or mustache, can affect your respirator's ability to protect you. Anything that comes between your face and the respirator's seal or gets into the respirator's valves can allow contaminated air to leak into the respirator facepiece, and you will not be protected. For example, if you have long hair, make sure it doesn't get between the respirator seal and your face, because this can allow contaminated air to leak into the respirator. Fit testing can be done by your employer or an outside party, including a union and apprenticeship program, a contractors association, or a past employer. Your current employer is permitted to accept fit testing you have received from an outside party, such as a former employer, within the last 12 months, as long as you use the same respirator make, model, style, and size at your new work site. This is known as fit testing portability. While recent fit testing can follow you from job to job, it is still your current employer's responsibility to ensure that the fit testing and record-keeping requirements of OSHA's respiratory protection standard have been met before you use a respirator for protection against hazardous exposures at work. Sometimes workers own their own respirators and bring them to a job where respiratory protection is required. If your employer allows you to use your own personal respirator for protection, then your employer still has to comply with all of the requirements of the OSHA standard. For example, your employer must still ensure that your respirator is appropriate for the hazards you face, your respirator is properly cleaned, maintained, and stored, and the proper schedule for replacing cartridges and filters is followed. Keep in mind, however, that while your employer may allow you to use your own respirator, your employer cannot require you to use your own respirator. This video has provided you with a brief overview of OSHA's fit testing requirements. There are many other things that you must know and do before you can safely use a respirator in a hazardous work environment. While this video may be a part of your respiratory protection training, your employer must also provide you with additional training on respirators, including worksite-specific training. Remember, if you don't know if a respirator is needed for the task you will be doing, or if you are unsure about how to properly use a respirator or which filter or cartridge to use, talk to your supervisor before entering the hazardous area. For more information about respirator use in your workplace, refer to these OSHA and NIOSH websites.
The third would be that you need to train your employees or have your employees trained. How to use a respirator, how to clean it, how to maintain it, how to sanitize it, and so on. So training.
OSHA requires the employer to provide effective training to employees who are required to use respirators. The training must be comprehensive, understandable, and recur annually, and more often if necessary. Here are OSHA's standards for training. Now, back to Charlie.
1, 2, 3 per employee annually. Now, depending on what your employees are exposed to, this medical evaluation may also include spirometry. Right? This is where they're going to blow into a machine and it's going to, measure the volume and make sure that they're in good condition. They're physically fit to wear a respirator. Spirometry is not always, a pulmonary exam is not always required. Some things that you may expose your employees to also require chest x-rays. All right? So it really depends. But you need 1, 2, 3 annually. In addition to these 3 things done per employee annually, you should have a written program. Within your health and safety plan, you should have something for everything, right? Fall protection, electrical hazards. and many, many others, and one of them being respiratory protection, a written program of the proper procedures and what you're going to do to keep your employees safe. So we have the permissible exposure limit for lead dust in the air, lead paint dust in the air. It happens to be 50 micrograms per cubic meter. 50 micrograms per cubic meter, 50 millionths of a gram, right? A cubic meter takes up, is about 2 mini dumpsters next to each other. That's about a cubic meter of space. All right?
Hold on, let's back up a bit. The permissible exposure limit for lead in the air is 50 micrograms per cubic meter, 50 millionths of a gram. You have to give your employees a respirator at half the permissible exposure limit, which would be 25 micrograms per cubic meter.
So if the permissible exposure limit for XYZ, is 50 micrograms per cubic meter, you have to give your employee a respirator at half of that, 25 micrograms per cubic meter. So before that, any less than that in the air is going to be what we call voluntary use. Voluntary use of a respirator does not require these three things right here. It's voluntary use. Once there's enough dust in the air to equal 25 micrograms per cubic meter or more for lead dust in the air, we need to provide them with a respirator. So in order to choose the proper respiratory protection, first we have to answer two questions. The first question is going to be, what is it? What is the contaminant? Is it this? Is it that? Is it crystalline silica? You have the new crystalline silica law that goes into effect June 27th or June 23rd of 2017 of this year. This requires you to treat concrete dust as if it were asbestos. This is a very stringent rule, which may get repealed under the current administration. I'll be honest with you. It's already on the chopping block, all right? But it kind of makes sense. And pretty much everybody in this room, during a demolition activity, or you're a tin knocker, you're putting hangers on the ceiling, drilling into the ceiling to hang your stuff, or using a powder actuated gun to shoot into concrete, or you're core drilling, or you're chopping, or you're breaking, or the guy's scarifying the road to do repaving. Through many, many different aspects of construction are we disturbing or pulverizing concrete. Now, how do we make concrete? What are the ingredients in concrete? We have sand, rock, right? Aggregate, and cement, what some people call Portland. Portland's a brand, so we have cement. And what else? What else? Huh? Water, right? Excellent, water. And then now, with concrete technology, we have a lot of additives, a huge amount of additives, chemicals, this thing, that thing, a lot of different additives to give us different strengths or for whatever different uses that we have, right? Well, when we, cut, chop, break, sand, grind, drill concrete through the rock, right? Inside the rock, inside the aggregate, inside the sand of the rock, you're going to have crystalline silica. And silica dust is like shards of glass, right? You breathe this in, and it's going to, scar your lungs, very similar to asbestos, all right? Somewhat different, all right? But it's called silicosis. And silicosis is scarring of the lungs, and you have volume, right? You breathe in, we have expansion and contraction. And scar tissue is more rigid, yeah? So as scar tissue builds up, the room inside our lungs gets less and less, and then you die, right? A lower life expectancy. Or you have a quality of life issue. You have a hard time breathing, as you get older. It takes time for something like that to develop. So the new silica law actually made a lot of sense. I hate to see it on the chopping block, but it is what it is. Whether it's asbestos or it's lead or silica, and on it goes on and on from there, right? What is it? We have to answer that question. What am I exposing my workers to? Am I using a paint stripper like Peel Away or Piranha? I'm going to look up those chemicals, right? And I'm peeling, I'm going to be stripping lead-based paint, so I have lead. And I'm going to look up those chemicals and lead inside the NIOSH Pocket Guide to Hazardous Chemicals. Whether I'm using the actual book, which is somewhat difficult to use, or I'm using the digital version, on CDC, Center for Disease Control's website, which is really, really easy to use. In here, I'm going to look up each one of those chemicals, each one of those dusts, each one of those products, right? And it's going to tell me the proper respiratory protection, or the proper filter, or the proper cartridge, or the proper filter cartridge combination to use, and then the level of protection to use based on how much is in the air. That is question 2. So the first question is, what is it, right? We said, first question is, what is it? Well, we're taking a lead class here today, but it could be anything. So what is it? You look it up inside here, and it's going to tell us what filter cartridge combination, or what cartridge only. All right? So, first question, what is it? I look it up. It's going to tell me what filter, what cartridge, or what filter cartridge combination to use. So we're talking about 3 different ways. All right? And then how much in the air is question number 2. How much is in the space that my workers are in? And that's going to determine whether this is okay, or we need to use a half face, or we need to use a full face, or we need to use PAPR, or we need to use supplied air or self-contained breathing apparatus. All right, so based on how much is in the air is going to determine the level of protection. And this is all based on leakage. This leaks, right? There's a lot more leaks in this, right? Everybody's worn this before, okay? You worn this one? You worn this one? Everybody's worn these before. It stops all the dust and debris like this, and then, there's a trail of dirt like this right up your nose. So this is not very effective, okay? We're going to get into all these in a minute, but the more contaminated the air, we have to move up in the level of protection. As we move up, this leaks less than this, right? So a half-face respirator is going to leak less than a disposable, dust mask disposable respirator. A full face is going to have less leakage than a half face. And then we get into powered air purifying respirator, which is going to supply us with positive air, is going to have less leakage, which I'll get into in a minute. So first, we need to understand, the filters that should be used for dust. The filters that should be used for gases, fumes, and vapors, and so on. And then if we're generating dust or not just dust, but particulates, right? Because smoke is also a particulate, right? So different types of particulates, and organic vapor, and gases, fumes, whatever it may be. We're going to have a cartridge combination. They come in many different colors. Each color is indicating what it's good for, if you will, all right? So this is, magenta from one manufacturer. This is for the particulates. Here we have magenta from another manufacturer. Here I have magenta from another manufacturer. Here I have magenta from another manufacturer. They all look like different shades of purple, right, or pink, but these are all magenta. High efficiency particulate air resistor. 99.97 effective at 0.3 micrometers. HEPA filtration, according to NIOSH's Pocket Guide to Hazardous Chemicals, is what's required for working with lead or asbestos or even maybe silica. All right? It's up to you guys to look at that and make that determination. I'm just kind of giving you how it works. All right? If I was working with something that was not as hazardous, maybe then I could use something less than high efficiency filters. All right. Again, it's in the NIOSH Pocket Guide to Hazardous Chemicals, or on the CDC's website, the digital version, which is actually really great. Based on how much is in the air is going to determine the level of protection. So I'm going to start at the bottom, and I'm going to work my way up. Now, each respirator has what's called an assigned protection factor, and that's based on leakage. All right, and that's a little too complicated. I don't want to get too carried away. Okay, but just to keep it in layman's terms, this has more leakage than this one. All right, but let's focus on this for a minute. This is an N95 disposable respirator, dust mask. This is an N95 with an exhalation valve. They are both the same. This one is not better than this one. They are both the same. This one helps breathe out a little bit easier, all right, but that's about it. The media that you breathe through is the same. It's got the same amount of leakage, okay? So the assigned protection factor for this is the same. Now this is an N95, this is an N95. These are 95% efficient. Makes sense, all right? Now we move up from there to the next level of protection, and that's going to be an N100. N100s come with or without an exhalation valve. Now, the media that you're breathing through is different. It's a different material. It's thicker. It's different, right? It's going to block more at a smaller size. And then the way it seals to your face is also different. So the seal to your face is much better. So you have less leakage. This is an N100. Now, don't get me wrong. It is not 100% efficient, okay? Here we have a P100. And this P100 is very similar. You'll see that it's magenta here. It's very similar, to magenta here. A little bit different because a half face, we get a better protection factor than a disposable. But the filtering media is very similar to what you would find in any other magenta. It says P100 here, right? So we have N, R, and P. All right, so N means not resistant to oils. R means some resistant to oils. And P means a little more resistance to oils. All right? N, R, and P. So those are disposables. Once the air becomes more and more contaminated, we need to move up to the next level of protection, and that would be a half-face respirator like this. When I breathe in, I get clean air through the filters or the filter cartridge combination, and I get contaminated air through leaks. Right? Half-face respirator like this, no facial hair whatsoever all around here, wherever this seal comes into contact with. Shave that morning, right? We call it baby bottom clean. Shave that morning. Or I'll send the guys to the store, buy a razor, and shave on the job. 1 or 2 day stubble is going to push the face piece out, and you're going to have more leakage. So it's much better to be shaven that morning, all right, when using, fully shaven when using a half-face respirator like this. We move up the line depending on how much contamination's in the room, right? And we are going to go to a full face. Again, I breathe in, I get clean air through here, I get contaminated air through my leaks. Now, whenever I wear a full face, I get a lot of leakage in my temples. I guess, I got some indents or something. Everybody's face is different, all right? I also get a lot of leakage here too because of facial hair. So no facial hair whatsoever all the way around here, except maybe you could have a mustache to the crack of your mouth, and that's about it with a full face respirator. Anything below the crack of your smile, right, the crack of your lips down, or any sideburns or anything up here around here that would come into contact with this outer seal would be unacceptable. We move up from there to a PAPR, Powered Air Purifying Respirator. So let me get us there real quick. And, here you see it in two different ways. So this is a PAPR with the filter and the motor, the blower, connected to the face piece. And here you see it, the motor, the blower, and the battery all in one, and the filter right here as well. With this particular one, the battery goes on your belt or in your pocket, all right? The drawback of this is all day long you hear. So let's forget about that one for a minute, and let me explain how this one works. So this has filters, okay? So it's showing magenta with yellow, which is very common. You'll see as people calling it all-purpose, all right? But it's really not, okay? So air is going to be drawn through here. This motor is going to pull the air through the filter, and air is going to fill the face piece. Now, because positive air is filling the face piece, air is filling this face piece, And that means the air is going to escape the leaks. So if air is coming out of the leaks, can I breathe in contaminated air through the leaks? No, not in continuous positive pressure, right? Now, I move up the line from there, and by the way, I like it much better like this. This one here is probably between $600 or $700. You know, you could get them. This is about, $800 to $1,200 or so. I put this on my back, right? I slide it around to my back so that when I'm generating dust, it doesn't get clogged up. And I can also connect this to the back of a hood, a disposable hood even, right? I put the hood on, it's disposable, so I cannot breathe in contaminated air through the bottom of the hood, and I don't have to shave. And it really is the best method to use. It's what we use a lot in asbestos and lead abatement, right? We move up the line from there to supplied air. Now, supplied air and SCBA are equally as good, but they both have their limitations or their drawbacks. So supplied air, we have a special compressor, usually outside the work area, running with a hose that runs to our facepiece. Filling up our facepiece with positive air, air escapes the leaks, so I cannot breathe in contaminated air through the leaks, sort of. I have a bottle here in case the power goes out. If the power goes out in this, then this is going to kick in, and now I have an emergency escape bottle. I can leave the work area. Now, what's awesome about this is I could work for many, many hours, all right? But I am stuck to a hose, right? So I'm limited as far as I could go. I really can't. Mobility is my limitation. But I can work for a long, extended periods of time. We move sideways, not really up, right? We move sideways, kind of, to self-contained breathing apparatus, right? This is scuba without the ooh. We're not underwater, right? So it's self-contained breathing apparatus. And the way you see it here is a very common setup that your emergency service personnel would use, your firemen would use. A fireman, though, wouldn't use this in continuous positive pressure. This is going to supply him with clean air blown into his facepiece, but most of it is on demand. So when he breathes in, or she breathes in, going to get a blast of air, but they have a slight positive pressure, but not that much. So they can be exposed to contaminated air through leaks. If I was evaluating a warehouse that the door hadn't been open for 50 years, and we're going to be opening this door, right, I'm going to want to wear the best level of protection. And that would be an SCBA, usually with a 1-hour tank, not a 30-minute tank, continuously pushing air into my facepiece, so continuous positive pressure, and that way when I enter, no contaminated air can come inside. So a SCBA can be used in 2 different ways, all right? Most emergency service personnel are not using it in continuous positive pressure. That 30-minute tank will last like 15 minutes before the 5 minutes of air goes off, and that just wouldn't really be very safe. All right, but when I did a job in New Jersey and we went in, opened up a door using colorimetric tests, and we were wearing the best level of protection, that's SCBA, but in 1-hour tank with continuous positive pressure. Now, this is great, but I am limited to time. It's nice because I could go in and out, this and that, do confined space rescue, do the evaluations, go here, there, but I am limited to time. So it's just as good as supplied air, all right, but it has its limitations, just like supplied air does, that I can work for a lot of time, but I can't go very far, all right? So both of these methods are the best level of protection available because we are not dependent on filters. There's no filters. If you move down the line from those 2, we have a filter. Even though this is positive air, I'm still dependent on filters. So I cannot work in oxygen deficient areas, right? Less than 19.5%. And I cannot work in heavily contaminated areas or unknown contaminated areas. You don't know what it is. That's even worse, okay? Because I have filters. Right? Do you guys understand the difference? They all have assigned protection factors, which is kind of confusing. You're doing math and all this wonderful stuff. But the bare minimum for lead dust, right, lead paint dust, is an N100. An N100 is the bare minimum for lead dust, okay? And this actually, this has an assigned protection factor of 10. So the permissible exposure limit is 50 micrograms per cubic meter. And this has an assigned protection factor of 10, so that means 10 times 50 equals 500. This is good for up to 500 micrograms of lead dust in the air, which is a significant amount. Only when you go above its assigned protection factor of 500 are you going to get into half-face respirators. But you can make it a corporate policy to use this anyway. It makes sense. It leaks less. It's a better type of respiratory protection. And these are disposable. You throw them out at the end of the shift or at the end of the day, whatever it may be. Now, there's a way to create a end of service life schedule. Some filters and cartridges, in combination of both, come with an end of service life indicator. They're usually very expensive. It turns a color when it's no good anymore. That's not what most places do or most companies are doing. You make a change out schedule based on leakage. Based on breakthrough. Right? So if I'm using this all day, right, and after 4 hours of doing a certain task, using some chemical or something or whatever I'm doing, after 4 hours I start to taste something or it's not working very good, then I know there's been breakthrough. All right? So this stopped working, let's say, after 4 hours while I'm doing task A. Okay? That means I write it down, and tomorrow when we're doing task A, after 3.5 hours, I'm going to change my filters, my cartridge. Make sense? That's a change out schedule. When you get breakthrough, when you taste it or you smell it, and that first time, now you create that time frame. Oh, it took 8 hours for this to happen. So tomorrow at 7.5 hours, we are stopping what we're doing and changing our filters or our cartridges. Make sense? That is a change out schedule or end of service life schedule. After we've used it, we're talking about cleaning, sanitizing, and then maintaining it. I can't stand when I see people throw the respirators in the gang box, throw them on the floor. You're using the same filter for a year. You take it in and out of the truck. Oh, yeah, you put it back on and off. You know, like this one here. I don't know. I think it was used for asbestos or something like that. Can you hold that for me right there, buddy, all right? It was used for asbestos. You hang on to that for me, okay? I don't understand why we don't treat these better. These are a valuable tool. Your employees should be trained how to use them before they're using them. It's a requirement for you to have your employees trained. Again, the bare minimum for lead is an N100 disposable respirator like this. This has an assigned protection factor of 50, which gets you up to, of 10. This has an assigned protection factor of 10, which is going to get you up to 500 micrograms per cubic meter of space. Now, how do they know how much dust or contaminated something is in the air? And that is called an exposure assessment. So you have a pump like this with a hose, and this pump is going to be worn for 8 hours by your worker, right? So he's going to wear this for 8 hours. Whoops. And depending on what is in the air, what you think is in the air, is going to determine the type of cartridge that is used. So your worker would use this. This is for asbestos, all right? And you know, inside this cap right here, maybe you could see it. It's a little white wafer, all right? So this is worn for 8 hours and multiple days in a row if necessary. So for 8 hours while the guy does work, while he eats breakfast, while he's doing this and that. And then this is going to go to the laboratory. The laboratory is going to count the particulates of whatever it may be, using sometimes a microscope, sometimes using atomic absorption spectrometry, sometimes it depends. And they're going to count that, and that's where they're going to come up with how much of that stuff was in the air for that task. Right? So now you have a number, and now you know what level of protection to use, whether a dust mask or SCBA. You know what I mean? So this one is for lead. Here you have one for lead. So for 8 hours, the guy is going, it's going to draw air through this, and this is going to go to the laboratory. The laboratory is going to count the particulates, and then give you a piece of paper stating that it was 150 micrograms, that day, right? So then what they're going to do is take the amount that was in here, divide it by 8, and they're going to come up with a time-weighted average, what that worker was exposed to, throughout the day on average. Because how in the morning, everybody kind of doesn't work that hard, and then you work really hard, and then, lunch comes and everything kind of dies down, and then after lunch, they work a little bit, but then they work really hard, and then towards the end of the day, everybody gets lazy again. So, through those peaks and valleys, they're going to determine, what is the average, right? A time-weighted average over 8 hours. That is going to help us determine what level of protection to use. What it is going to determine whether it's a filter cartridge combination, cartridge only, or filter only. So what is it? That's going to help. That's going to help us determine this by answering that question. How much in the air doing an exposure assessment is going to help us determine the level of protection we use. Everybody understand that? It's a little extended, information, but very, very valuable.